All right. Hi, everyone. This is lesson 5.4, part 1, only doing indefinite integrals today. There is another section to this chapter section, and it's going to be done when we do chapter 6. Okay, so 5.4, indefinite integrals. There's not a lot new today, actually. Just kind of a review of what an antiderivative is. Last day, we learned the fundamental, or last lesson, you learned the fundamental theorem of calculus, and that derivatives are essentially the opposite of integrals. So we can actually evaluate an indefinite integral, which means that there are no bounds on the integral, because we know that an integral is the opposite of the derivative. So if we want to find it's just the antiderivative. And we learned that in section 4.9. So we can evaluate integrals without bounds. It's just finding the antiderivative. Okay. So some common ones you need to know, or some common rules that you should know. The top two are not how to evaluate the integrals, but that you can separate them in certain ways. So just like derivatives, if there's ever a constant in front of your function, you can just simply ignore that constant and it just gets multiplied into the answer. So you can even remove it from the integral and put it on the outside if that simplifies things for you. Also, if you have any terms that are being added or subtracted, you can simply just consider them separately. You cannot do that with multiplying and dividing, but you can do that with adding and subtracting, just like you would when you're taking derivatives. Okay, and then below these two rules are all the antiderivatives that you'll get to know by heart. So the first one here, this is the opposite of the power rule. So when we're doing the antiderivative of x to the power of anything, you would bump that number up by 1 and then divide by that number. We've done that a lot in 4.9. Antiderivative of e to the x is just e to the x. Notice I'm putting plus that constant on every single term here. That's because there could be a number there that's added on. And so you do have to add that plus c. Okay, 1 over x would be ln x. We do add absolute values because x has to be positive when it's inside a ln function. So the absolute values are there. The antiderivative of cos, secant squared, and sine are all there too. So you have to know those 6. Those are the main rules you'll be dealing with. Okay, so let's do some examples. It's going to be a pretty short lesson today because we did a lot of this in 4.9, but now it's just a different notation. So essentially here they're asking us, what is the antiderivative of 10x to the power 4 minus 2 secant squared x minus 5? Now, if there's a lot of terms being added or subtracted and you find it easier to separate them out, you can do so. So here's one option of how you could show your work. Now, you don't have to do this. If you're able to just do this in one step, that's fine too. But I'm going to write it in separate steps, just especially the first time we're doing this. So it's the antiderivative of 10x to the power 4 minus the antiderivative of 2 secant squared x minus the antiderivative of 5. Okay, so let's do each one separately. So this would be, here we're bumping the power up by 1 and we're dividing by that number. Okay, the 10 just stays. 10 is just a constant. It just gets multiplied to the answer, okay? Same with this 2. Okay, then the next one would be 2 times, so the antiderivative of secant squared would be tan x. That's because the derivative of tan x is secant squared x. That's one you'll just have to memorize. And then the antiderivative of 5 is 5x. That's because if I take the derivative of 5x, it'll be 5. And then I need my plus c. Now let's write this a little bit nicer for my final answer. 10 divided by 5 is 2. Don't need the dot for the multiplication. It's implied when you write the numbers next to each other. There we go. Okay, and you can always, and I would totally recommend doing this on a test or something, you can always do a check. Okay, take the derivative of what we just answered and make sure it's the original function that was in the integral. Okay, the derivative of 2x to the power of 5 would be 10x to the power of 4. Yep, that matches the first one. Derivative of 2 tan x would be 2 secant squared x. Yep, that matches the second one. and the derivative of 5x would be 5. Yep, and then the derivative of c would be 0. Cool, so it does match. So always, always, always do that check, especially on a test. It's easy to get mixed up between derivatives and antiderivatives, and sometimes you make a little silly error here or there, and you want to avoid those. So always do a check. Okay, let's do this one. Now, we don't have a rule yet for any quotients. Here we have a quotient or a division. So we need to simplify it first and break it up. Okay, so we can actually write this as two separate fractions. If there's only one thing in the denominator, I'll show you. X e to the x over x minus 2 over x. That's because with a common denominator, you can simply put those back together and it would be one fraction again. We can split this up and simplify it even more. X over x is just 1, so it'd be e to the x minus, and if you want, you can pull the 2 out, but you don't have to. I will do it. The x. Again, you don't have to pull the 2 out, but sometimes it's easier for students to see. Okay, now we're actually going to answer this. The antiderivative of e to the x is just e to the x. The antiderivative of 1 over x is ln x. And we need to put the absolute values just because x can't be a negative number or won't be defined. And plus c. There we go. Done. And you can check again and you'll get this back. So if you have any kind of quotient like that, you need to separate it into two fractions before you can do the antiderivative. There's going to be some things that won't be able to be separated. In that case, you can't do the integral yet. We just don't have the tools. We are going to be learning some tools for certain types of integrals, but we don't have a tool yet for any quotients, so you need to separate it. Okay, and that is it. Yeah, that's the end of the lesson. So it was a short one today.